In this lecture, we are going to begin the next section of this course, which is all about modern portfolio theory and the capital asset pricing model. This section will introduce you to some of the most fundamental ideas in modern finance, such as diversification, the Sharpe ratio, the efficient frontier, and the capital market line. To give you some idea of how this section fits into the rest of this course, I think it follows a very logical progression. First, we started with just trying to understand one of the core financial measurements, the return on an asset. We asked, what is the distribution of the return? How can we characterize that distribution? In the next section, we started to look at the return as something that is time varying. We asked, how does the return change over time? And can we predict those changes based on how it has changed in the past? One of the major lessons we learned during that exploration was that predicting returns is pretty hard. If we could predict stock returns, we wouldn't need to know about portfolios in the first place. Logically, if we can predict the return of every stock, all we have to do is pick the best stock. Any portfolio would thus be suboptimal. In this section, we begin to accept the fact that this is not possible and that creating a portfolio of stocks is a more realistic solution. Let's now outline what we will discuss in this section. We're going to start by looking at probably the most famous portfolio, the S&P 500. This portfolio has not been created using the techniques in this section, but it is a real-world example of a portfolio. Next, we're going to define risk, and we're going to look at a concrete example of how diversification helps to mitigate risk. So this is one of the first concepts you will learn in this section. Risk is bad, and creating a portfolio reduces risk. Hence, portfolios are good. Next, we're going to discuss how to characterize a portfolio in terms of two important quantities, its expected return, known as the mean, and its variance. The mean and the variance of a portfolio are extremely important quantities because what we are going to end up doing is called mean variance optimization. That is, we're going to look at how to find a portfolio with the best mean and the best variance. Obviously, you don't know what I mean by that yet, but you will. We'll be looking at two convex optimization techniques known as linear and quadratic programming. These techniques are what allow us to solve for the optimal portfolio given a set of constraints. A constraint is something that limits how you can invest. For example, you can't invest more than 100% of your wealth. As mentioned previously, this groundwork will then lead us to some of the most fundamental concepts in finance, such as the efficient frontier, the Sharpe ratio, and the capital asset pricing model. This is yet another section of this course that became way more massive than I had planned. Although I didn't get to cover every topic I wanted to, I think this section goes over most of the topics that I think are fundamental to financial engineering. Thanks for listening, and I'll see you in the next lecture.